And here are answers to Orgo quiz number 3. Definitely skip through the video and find just the questions that you want to review. So question number 1, which of these reactions proceeds by a free radical mechanism in the presence of UV light? We're talking about alkanes and halogens here. Remember that if you have an alkene will go through an addition reaction. Since we're talking about free radical, this is substitution. So we need to find the alkane, single bonded carbons, and then a halogen. This one is not it. This is benzene. This one is not it. Also benzene. These two are looking promising, but CH2, CH2, C, only 2 H's, C, only 2 H's. Remember that carbon needs a valence of 4, and right now each of these carbons only has 1, 2, 3 bonds, which means this is a double bond. This is going to be the alkene that's going to go through an addition reaction, even in the dark. And so our answer is going to be this one. So CH3. CH3 means that single bond gives each carbon its valence of 4 bonds on each carbon, plus Cl2. In order to make this happen, we need to go through that homolytic fission using that UV radiation to get those 2 chlorine-free radicals, which will then go and attack that ethane and eventually will make some chloroethane and some hydrogen chloride. Good? Good. Number 2, which can be formed when CH3, CH2, CH2OH is heated. Let's draw that so that we know what we're looking at. CH3, CH2, CH2, and an OH. This is an alcohol with that hydroxyl group. We have 1, 2, 3 carbons, so this is going to be meth-eth-prop. This is propanol. And we could clarify that it's 1 propanol, because I would actually start counting carbon number 1, 2, 3, since the hydroxyl group is special and carbon number 1 gets the special stuff. So this is 1 propanol because the hydroxyl group is bound to a carbon that is bound to only 1 other carbon. Those are hydrogens, not carbon. This is a primary alcohol. Primary alcohols can go through oxidation when heated with acidified potassium dichromate, or we could have acidified potassium permanganate, and we can make first an aldehyde, which would look like 3 C's and a double O, and then lots of H's. I get to keep this aldehyde if I distill out that product, but if I put that aldehyde through reflux, I heat and mix and heat some more, we can actually turn that aldehyde, the carbonyl group there at the end, into a carboxyl group. We'd still have those 3 carbons, and so I can do 3 H's, 2 H's, so that each carbon has those 4 bonds. So we can make this guy, which is meth-eth-prop, propanal. That's this one right here. We can make propanal. If I distill out the product, we can make propanoic acid. Propanoic acid is Roman numeral 2. If I put that product under reflux and continue oxidizing, there is no option for making this guy, which would be propanone. Those ketones are made only if we have a secondary alcohol, and here we have a primary alcohol. So our answer is going to be 1 and 2, Roman numerals 1 and 2 only. Question number 3, major product between HCl and but2ene. Meth-eth-prop but. Carbon number 1, carbon number 2 gets a double bond. Fill in everything else with all the hydrogens that are needed so that carbon has its valence of 4. It doesn't matter, these hydrogens that I put on the carbons with the double bond. It can go tops and bottoms, or both on the top or both on the bottom. It doesn't even matter. So HCl, because I have an alkene, this double bond, this is going to be what we call an addition reaction. I'm going to add the HCl. We're basically going to break this double bond, make it a single bond, and I'm going to add the H and the Cl into the molecule, which is why we call it addition, right? So now how do I name this guy? I'm going to count carbons 1, 2, 3, 4. I have a chloro group on carbon number 2. I started counting from this end because we always give we start counting at the end closest to the special group, and chlorine is special. So carbon's number 1, 2, 3, 4. We're going to call this 2-chloro-meth-eth-prop-butane. 2-chlorobutane is our answer for number 3. Number 4s and 5s. This is just naming things. So I see here that we have a carboxyl group in this aspirin molecule. We've got this phenyl group here, but phenyl is not an option in my question. Notice that we've got here COO and a single O and another C. This is my ester group. I don't have an ether in here. So yes, 2 and 3, but not 1. Our answer is choice C. Number 5, what is the name of this guy? Notice OH and O. There's a carbon here. This is a carboxyl group. And so I'm going to start counting here, carbon number 1. The carbon in the carboxyl group always gets carbon number 1. 2, 3, 4. 1, 2, 3, 4. We have a methyl group here on carbon number 2. So I'm going to call it 2-methyl-meth-eth-prop-butanoic acid. 2-methyl-butanoic acid. 2-methyl-butanoic acid. Question number 6. Which molecule has a tertiary nitrogen? I'm looking for a nitrogen that is bound to 3 carbons because tertiary means 3. So let's start with this guy. I've got NH, CH3, CH3. This nitrogen is bound to 2 carbons. That makes it secondary, not tertiary. This is not it. This guy is weird, and so no. Look, it's bound to like 4 carbons. That's not it. Let's look at this guy. I'm going to start with the N in the middle. N is bound to 2 methyl groups, CH3, CH3. On the other end, I have meth-eth-prop, a propyl group. 1, 2, 3 carbons with those 1, 2, 3, 4, 5, 6, 7 hydrogens. Notice that this nitrogen is bound to 1, 2, 3 carbons. C is our tertiary nitrogen. This guy, I'm going to draw choice D down here. So I've got N and 2 H's. So this nitrogen is bound to 2 H's. We already know that it can't be tertiary because it's only primary. And then these 6 carbons are going to go over here. Those 5 hydrogens means we've probably got ourselves a little bit of a ring going on. Good? Good. Number 7. Halogen and ethane. This is an alkane. Alkanes are going to go through free radical, I can spell, substitution, free radical substitution. So our answer is going to be either A or B. Alkenes, like if I had ethene instead of ethane, then this would be an option. Addition reactions are alkenes, free radical substitutions are alkanes. That halogen, for example, I could have chlorine, needs to go through some UV radiation and turn into 2 chlorine free radicals. We call this homolytic fission because I need there to be unpaired electrons on each of those chlorine atoms. So homolytic fission, not heterolytic fission, free radical substitution. Our answer is A. One more question. Number 8. We need to convert ethanol into ethanal. This is a primary alcohol. Ethanal is an aldehyde. Remember that if we want to convert a primary alcohol into an aldehyde, we are going to oxidize it. We're going to oxidize it with either acidified potassium permanganate or acidified potassium dichromate. If I want to keep the aldehyde, we have to distill out the aldehyde. Otherwise, more oxidation will occur. More oxidation. Ooh, spelling is hard. If I want more oxidation, I can turn this guy into a carboxylic acid. If I don't want the carboxylic acid, I need to reduce the oxidation. I want to limit the oxidation, which means that I don't want excess oxidizing agent. I want less. I want to limit that oxidizing agent, which means A and B are out. So our answers are C or D. If I want to keep the aldehyde, we have to distill out the product. Our answer is choice D.